Good morning and good afternoon to everybody who is present in this session. I am going to start my presentation on behalf of Sri A.K. Sharma, PDG of Satellite Meteorological Division of India Meteorological Department on my behalf. I will present all the presentation, complete presentation, and Dr. Sharma is busy somewhere, so he is not available. So now I will go to my topic, the operational use of to the imagery access of data of INSAT-3D satellite for the forecaster and trainer. At present, India Meteorological Department have 3 operational satellite, Kalpana 1, which is located at 74° east, INSAT-3A, which is located at 93.5° east. They were launched in 2002 and 2003 respectively. Recently, we have launched INSAT-3D satellite, which is located at 82° east. So I will concentrate on INSAT-3D satellite images and product. INSAT-3D satellite is an advanced meteorological satellite which was launched on 26 July 2013 from the French Guiana using Ariane rocket, and it is located at 82° east. The mission objective to monitor the Earth's surface, carry out the oceanic observation and its environmental various spectral channel of meteorological importance, to provide the vertical profile of temperature and humidity parameter of the atmosphere, to provide the data collection of data destination capabilities from the data collection platform, to provide the satellite aided search and rescue services. The basic payload carried by the INSAT-3D are 6-channel imager, 19-channel sounder, satellite aided and search and rescue operation. Meteorological payload are state of art and have significant technological improvement in sensor capabilities and higher resolution compared to our INSAT mission earlier. The 6-channel imager, it basically sends the visible to thermal infrared 1 kilometer to 8 kilometer instantaneous ground field of view, half-hourly earth coverage, flexible scanning mode, programmable number of line and frame as per requirement, improved black body calibration scheme, image motion and mirror motion compensation is there, and the visible sounder payload is basically having the capability to scan the earth visible to long infrared IR wave, and fully programmable east, west and north, south pattern is there, programmable dual time for the east, west scan, step motion is there, automatic space view every 2 minutes and black body view every 30 minutes, 10 kilometer instantaneous ground field of view, 14-bit digitization, image motion and mirror motion compensation. Have the improved 1 kilometer resolution in the visible band for monitoring the mesoscale phenomena and severe local storm, imaging the middle infrared band to provide the nighttime images for low clouds and fog, imaging in 2 infrared for estimation of the sea surface temperature with a better accuracy as a split channel. Higher spatial resolution in the thermal infrared band as it was 8 kilometer in Kalpana 1 and INSAT-3. The silent feature of the INSAT-3D imager are as follows. Black body calibration sequence is modified as compared to VHHR of earlier satellite. 3 flexible mode of operation which are mentioned below. The high resolution mode in the east fast scan direction, instantaneous field view are oversampled by 1.75 times and which are removed during processing. Biannual rotation of the yaw by 180° has been introduced to reduce the cooler patch temperature. This is to be taken care during the processing, and this utility was not available over the Kalpana 1 or INSAT-3A. So these mode of operation are given. At present, we are operating INSAT-3D imager in the full frame mode. So after every half an hour, we getting the image from INSAT-3D. We generate the different globe and sector images, and these are the steps allowing to generate the images. Radiometric and geometric corrected gray count values of respective channel along with lat long values are taken from the L1B data set, which is available in the SDF file format. All bands of the which images corresponding to SDF file name are assigned. Resampling of data over a fixed grid is carried out. The color lookup table enhancement is applied if it's specified in the configuration file, projecting the satellite image data into the proper map projection with constant spatial resolution and aligning the same to the true north. So that data can be overlaid on the map. For this, corner coordinate are given at a priori, and these are the converted into map projection coordinate in the desired projection. Grid line at configured interval are plotted, and set of coastline or political boundaries which are also configured are plotted. The output is saved in the JPEG or ZIP or PNG as per our configuration requirement. These are the detail of the channel of insert 3D images available. The visible spectral range is 0.55 to 0.75 micrometer. Spatial resolution is 1 kilometer, and purpose it is used for cloud surface feature. Short wave infrared, its wavelength range is 1.5 to 1.7 micrometer. Resolution is still 1 kilometer, and it is used for snow, ice, and water phase in the cloud. And the mid-infrared wave, the wave spectral range is 3.7 to 3.9 micrometer. Spatial resolution is 4 kilometer, and it is used for cloud, fog, and fire purpose. Water vapor spectral range is 6.5 to 7.5 micrometer, and spatial resolution is still 8 kilometer. Upper tropospheric moisture is being monitored with the help of this. The thermal infrared one, long wave infrared 10.3 to 11.3, spatial resolution is 4 kilometer, and it is being used to cloud top and surface temperature features. The thermal infrared 2 split channel is there, 11.5 to 12.5. The spatial resolution is still 4 kilometer, and it is used for lower tropospheric moisture purpose. You can ask the question whenever you feel free. As I told you, we are generating the different channel images of full disk, Asia-Mer sector, northwest sector, northeast sector, and high resolution images with district boundaries that is further divided into the 4 sector: northwest, northeast, southwest, and southeast sector of Indian region. These are the sample of images is shown here. This is a full globe images of visible channel. This is Asia-Mer sector. This is district boundaries images is there. So these images are used for monitoring the mesoscale weather feature such as the cloud cover, air mass boundaries, convergence zone, thunderstorm, and the local snow cover, limited to daytime use. Short wave infrared channel is as we know the property of the short wave infrared that it is being absorbed by the presence of water, snow, ice, and reflected by the cloud. So therefore, it is if we use this in conjunction or in association with the visible image, we can easily identify that which portion of the cloud can give the have a capacity of rain giving. And again, it is used for daytime use only. And if we see here, this is the fog is being shown here. This in the this fog image is being shown here. This is the sun glint is there on the image, and this is a full globe image is there. So here that both the visible as well as the short wave infrared images has been shown together. This portion of the portion is showing the cloud over in the visible picture, and corresponding this is a gray portion. It means this portion is having rain giving capacity here. So mid-infrared, as the mid-infrared is used both the reflected portion as well as the emitted portion. So this 3.9 spectral band energy measured by the satellite can be mixture of solar radiation that is reflected by the Earth surface or cloud and radiation that is emitted by the Earth surface or cloud. Characteristic of the reflected and emitted radiation in this band are different from the either the visible or 10.7 micrometer band, thereby promoting the enhanced capability of insert imager, multispectral imagery useful for fog and other liquid water cloud identification, cloud phase changes, distinguished cloud cover over a snow field, and fire detection. So these are the sample of images shown for the various purposes can be used for the mid-infrared. This is water vapor sample of images can be used for the upper level water vapor. This image is used to define upper level flow pattern, upper level circulation, and short wave moving through the flow. So this is the insert 3D thermal infrared IR1. This is the sample image. This is the atmospheric window channel, and as this is not a contaminated channel, so this is used to monitor the cloud top and surface temperature, cloud cover, air mass boundaries, convergence zone, and surface lows, and thunderstorm both day and night. This is thermal infrared 2, which is considered as a dirty channel because it is contaminated with the lower level atmospheric water vapor presence. Hence, it is used to achieve the higher accuracies of the sea surface temperature and noise correction in RTO mode. And these are the sample of images of all the 6 channel of the in the globe format. These are the sample images of all the 6 channel in the Asia-Mer sectors. So here it is a animation of Fallin cyclone observed through infrared 1 channel during the 7th to 12th October 2013, just at the time of INSET-CD was launched. So you can as the cyclone identifying the eye and the circulation well structured cyclone images can be seen in this animation clearly. And this has enhanced the capability of India Meteorological Department in forecasting of the cyclone events with a better accuracy. The next animation is western disturbance observed in the 10th to 12th March 2014 in a water vapor band. And you can see the animation now. See, the upper air circulation is being depicted in the image to form, and this can be easily watched in the animation. How clearly feature can be seen in this animation. We also start generating the daytime microphysics and nighttime microphysics on the line of international satellite operator, and this we have designed in consultation with the EUMETSAT scientist, and the recipe we use for the generating the nighttime microphysics is red color is a difference between the infrared 2 and infrared 1, and temperature range is -4 to +2 Kelvin with a 1% gamma enhancement, though international agency using 2.5% gamma enhancement, but it was in our case it is best for 1% enhancement. Green color is IR1 minus thermal mid infrared, and temperature range is -4 to 6 Kelvin, and gamma enhancement is still 1%. Blue color is used IR1 brightness temperature range is 243 to 293 Kelvin with a gamma 1% element. In the image you can see this is the dust cloud over the West China. These are the low level cloud or fog present here, and these are the thin cirrus cloud present here. These are the another sample images of fog seen through the nighttime microphysics is there. This is the nighttime microphysics images is there, and corresponding there is a fog product is there. And this is again another fog image is there, and then the fog is seen here. So these are the fog product itself we generated along with the nighttime microphysics. Here, this is a thin cirrus cloud can be seen in the dark blue shade is there. These are the interpretation of different color. These interpretation is being used as per international communities, and the same color scheme are used to identify different type of cloud present here. This dark brown color code thick and high level cloud is there, and this dark brown with the very cold this high level cloud thick layer is there. Then the thin cirrus cloud in the blue color. Oceans can be seen in the this and land this, and these are the thick mid level cloud is there. this portion, and then this is the thin mid-level cloud. This is the low-level cloud or fog is there. This is low-level cloud over warm atmosphere as Africa. Another product being generated by the IMD is daytime microphysics. Is there the recipe for the daytime microphysics? Red color visible channel reflectance range is 0 to 100% with gamma 1% gamma enhancement. Green color is short wave infrared. The reflectance range is 0 to 60% with 1% gamma enhancement. Blue color is IR1. BT temperature is 20 plus 203 to 203 Kelvin with gamma enhancement of 1%. And this you can see in this here, this is the cirrocumulus, no rain cloud is there. Then this is the snow is there in a pink shade, and this is the mid-level orographic cloud seen in the yellow color. This is the interpretation scheme being used for the different colors generated in the day microphysics. This is the CB cloud can be seen in the dark orange, then CB cloud with a small droplet slightly less dark orange, and water cloud with a small particle in this color. Marine stratoline cloud is this, shift trail is this, and then mid-level orographic yellow, and the cirrocumulus is this color, and snow can be seen in pink color. So here you can see an example of the dust over the Arabian Sea. This is the dust seen in the daytime microphysics. This is the dust seen at microphysics of the same event over Arabian Sea. This is another example of dust. This is dust in day microphysics. This is dust in night type of microphysics over Rajasthan region. See, we have also started online visualization and analysis tool that is called RAPID. It has been developed by the Space Application Center, ISRO, and being used operationally at India Meteorological Department on the through web service basis. And we can see an example of a dust storm over Rajasthan. This is the, if you see, this is dust here. This is dust here. This whole thing is dust here. And if we, because this rapid system have a utility to measure the numerical value of any point time series along with the time series, and in this the visible albedo is being shown the 35%, and the sphere albedo is being 37%, and the temperature is 293. So this will this can be used as a threshold. These values can be used as a threshold values to define the various weather phenomena. And this tool has been appreciated by the forecaster to a large extent, because this there was a problem in images, because images cannot have a high resolution images due to the large area coverage. In this, we can zoom any portion of the cloud images to any extent, and we can achieve even a native resolution. This is another example of animation of storm observed during the 30 to 31st May 2014, and it is started from the Jammu and Kashmir and basically reached up to the Bihar state and had given the widespread weather activities during that. You can watch the animation now. So this has covered from Jammu Kashmir to the West Bengal, up to West Bengal. This is here the thunderstorm over Haryana, Rajasthan, UP seen in the daytime microphysics through rapid visualization tool on 28th October recently at 11 UTC. And you can see these are the different things is there. These are the all thunderstorm cloud is there, widely covered. And if we see the in the thunderstorm, visible albedo is 100%, and SUIR albedo is less than 25%, and the temperature of the IRBT temperature is around 236 Kelvin and less than. So whenever this type of situation is being seen in the images through rapid, it means it is certain that that cloud is going to give good weather. So this is the associated hydroestimated rainfall seen through that thunderstorm storm over Haryana, Rajasthan, UP seen in the 28th October daily product. If we see the value of the hydroestimated rainfall on the this day is observed at 14 millimeter on that day. This rapid utility is also having to provide the time series data of last 3 to 5 days, and this we can see at a particular location. We can see the time series data of brightness, temperature of thermal infrared channel and this can be seen at any locations just by click. We also start generating the dedicated cyclone images by using the BD enhancement curve and northern hemisphere cyclone enhancement curve, and this exercise was started from the Hudhud cyclone, and this was successfully being used nowadays on an operational basis. And if you see this is the center can be seen in the BD curve enhancement images, and this is the center seen in the NSC curve of cyclone enhancement. So we are adopting all the type of enhancement being used internationally for this type of purpose. So this is the animation of Hudhud cyclone, which was well appreciated worldwide, and it is well predicted by the IMD by using the satellite images, and this is an example of that. Now I play the animation of the Hudhud cyclone. So in the animation we can clearly see that center is being formed and it is progressing towards the coast. So it can now you can see that the center has been formed, and now it will further move towards the coast. This. Here the clear cut center can be seen now with a red dot. So this is another example, because this cyclone, Chapala cyclone or Bensi can be seen, but I have not did the animation of this cyclone because this remained in the sea for a longer time. Size was too much big, and it can be seen from here in the image. This is IR images. The center can be seen here in this. This is center of the this cyclone on the 30th October 2015. And this is the BD curve images corresponding the same time. This is NSC curve images corresponding to the same time. And these are the images of BD curve when cyclone actually hit at the Yemen coast on 2nd November 2015 at 22:00 UTC, and it can be seen this is a center here. Here the center is there. Then we can see the next image is the NSC curve images is there. This is a center location is there on the coast. This is the corresponding rainfall associated with a paracyclone seen on the 3rd November 2015. You can see here there is a large scale rainfall event here is there around 374 millimeter rainfall can be seen in this areas, this range. So just we have seen the images example of generated from the insect 3D imager. Now as we know the level, there are 3 type of level data is generated from the any satellite. Level 0 raw data for internal use and archival, level 1 full globe data and sector data, level 2 geophysical parameter data, level 3 is bin geophysical parameter. So these are the nomenclature used for the data level as per the standard scheme in SDF5 format. Level 1 be full disk, level 1C sector data, level 2 be data available with per pixel values, level 2 is point data, level 2G is gridded data, level 3 is bin data of different products. We generate the around 12 dedicated products from insect 3D imager, just like cloud mask and outgoing long wave radiation, quantity of precipitation estimation, which is further divided into the 3 categories, GPI, IMSRA and HE by using different algorithm. Then sea surface temperature, snow cover, fire. Then we also generate the smoke, aerosol, cloud motion vector, water vapor wind vector, upper tropospheric humidity and fog product on an operational basis. These are the detail of the different geophysical parameter derived from this, along with the name and the value available on that. The outgoing long wave radiation is L2B. It is being available per pixel. SDF5 format is there. Rainfall using hydro estimator, again L2B, that is available per pixel. Fog L2C, that is available. Snow, that is also available per pixel. Cloud mass per pixel. Upper tropospheric humidity per pixel. Per pixel meaning here is that 4 by 4 kilometer. Land surface temperature, these are the recently we started land surface temperature in an insolation. They are being used for agrometeorological purpose. That was the requirement from the agrometeorology scientists to generate such type of product for them, and we started doing so. So fire is being generated in the point format. The smoke is also generated in point level. Atmospheric motion vector is also point level. Then we having insect multispectral rainfall algorithm that is generated at 0.1 by 0.1 degree. Quantity precipitation estimation QP, that is 1 degree by 1 degree. Aerosol optical depth is 0.1 by 1 degree grid. So I will cover one by one in detail in subsequent slides. Similarly, these are the 8 parameters which also generated on a daily, weekly, monthly and yearly basis as per the requirement. So first product is outgoing long wave radiation. Its unit is watt per meter square. OLR product is derived using the thermal infrared 1, thermal infrared 2 and water vapor channel radiances from insect 3D images. A genetic algorithm based empirical relation is used to define the broadband OLR in terms of the narrowband radiances from infrared channel and the satellite zenith angle beta at a given point. Generic form of the product algorithm is given. OLR is a function of the TIR1, TIR2, water vapor beta. The coefficient has been calculated by using the ISC data set. The product resolution is per pixel and the spatial resolution is spatial resolution is per pixel is there. Time resolution is 30 minutes. Product range is 50 to 400 watt per meter square. Product accuracy is 10 watt per meter square, and relative is 3%. And we have validated the result, and they are coming well within the range of that accuracy. This is the example of OLR. This is the example of daily OLR. This is daily OLR. This is monthly OLR. And we can see the pattern in the monthly clearly. Latitude-wise pattern can be seen in the monthly OLR images clearly. We also use the insert CD OLR average value of the box 5 north and 70 to 75 degree east box as a one parameter to declare the onset of monsoon along with the other parameter set. So, and whenever the OLR value, average OLR value of this box is reduced less than 200 watt per meter square, this is consideration for onset of monsoon. So another product we generated is sea surface temperature. The unit is measured in Kelvin. Sea surface temperature is achieved over a cloud-free region using geolocated thermal infrared 1 and thermal infrared 2 brightness temperature of insert 3D imager channel during the daytime, and mid-infrared is also used during the nighttime. Algorithm is based on the relative transfer simulation as per the insert 3D channel specification and viewing geometry. Provision are made to retrieve SST in case of failure of any of the split channel. The product resolution is per pixel. Product size is 50 degrees south to 50 degree north, 30 degree east to 130 degree east. And spatial resolution gridding with the warmest pixel is there. Time resolution is 30 minutes, daily, weekly, monthly, and yearly. Range is 280 to 308 Kelvin. Product accuracy is 1 Kelvin during night time with a noise 0.12 noise. And 0.8 Kelvin during daytime with a noise 0.12 K noise. These are the example of SST can be seen. This is the current current images, half hourly images is there. This is daily images is there. This is daily images. Here I have tried to depict that how we can use SST in the forecasting purposes. If you see, this is the 1st July 2014 images there, and there is a sea surface temperature. If you see here in this 2nd July, this has been increased, and corresponding on the 3rd July, this is a good formation of cloud can be seen over this region. This is the cloud region where the cloud has been formed. So SST link with the cloud formation over the sea region. This is the another product, upper tropospheric humidity. The specifications unit is the relative humidity is there. UTH product is derived primarily using water vapor channel of insert 3D imager and thermal infrared channel for cloud detection and filtering. An algorithm based on the analytical expression derived by the Soden and Britton 1996 and used to define the broadband this. UTH in terms of water vapor channel radiance from the infrared channel at different satellite zenith angle. The analytical form of the UTH is given by logarithm UTH upon P0 P cos theta is equal to A plus B T TB water vapor channel. And product resolution is 4 by 4 kilometer at nadir. Product size is there, domain is there, 30 to 140 degree east and 55 south to 55 north is there. So time resolution is 30 minutes, product range is 0 to 100%, absolute accuracy is 10% and relative is 30%. In this you can see the example of that. This is the half hourly images there. This is the monthly images there. In this you see latitude wise, here also you can see the latitude variation of upper tropospheric humidity present, clearly captured by the images. Another product of rainfall estimation is the IMS array this product unit is millimeter per hour because it's half hourly basis when it is derived. The QP product are derived using thermal infrared and water vapor channel brightness temperature from insert 3D imager. A multiple regression based algorithm empirical relation is used to estimate QP from infrared channel after calibrating this with micro based rainfall estimation from the trim precipitation radar TMI SSMI. The generic form of the product algorithm is given below. The product resolution is 0.1 into 0.1 degree and product size 30 to 120 degree east and 40 south to 40 degree north is there. And special interpolation box aggravation is there. Time resolution half hourly, product range 0 to 20 millimeter per hour. Relative product accuracy is 20%. Sorry, 40%. And if, here I have tried to show, if you see, these are the infrared images of various days is there, and corresponding rainfall estimation can be seen in the lower side of the images, measured by the IMSRA algorithm. This is another rain estimation product is there, hydro estimator, known as hydro estimator. Unit is millimeter per hour. Product is derived by using thermal infrared along with the NSF and JSF parameter and the earth evolution model. Thermodynamics model is used for calculating elevation LNB correction for warm rain. Orographic correction is carried out using the wind and elevation model. Dry atmospheric correction is carried out using RH, and rain is determined at each pixel using different relationship for convective and stratiform type of cloud, and relation dynamically calculated for each pixel is there. And when we have carried out the validation of this product, and it has been seen that this product is well captured the heavy rainfall event, which are missed out in IMSRA rainfall event. So product resolution is 4 kilometer by 4 kilometer. Product size is 0 to 40 degree north and 65 degree to 100 degree east. The time resolution 30 minutes. Product range is 0 to 150 millimeter per hour. Product accuracy is RMS root mean square deviation is 0.28 millimeter per hour. That is 46.95 millimeter per week compared to our MAT subdivision weekly rainfall IMD report is there. Similarly, relative humidity, relative product accuracy is root mean square deviation is 0.84 millimeter per hour compared to 3 hourly 0.25 by 0.25 degree trim B 3B42 rainfall estimation. Here again in active monsoon season during July 2014, we have shown the images of IR1 channel in the top of this slide, and below there is a rainfall event measured by the hydro estimator. These are the rainfall seen in this case. Here, as I told you, that hydro estimator is well capable to capture the even heavy rainfall event which are normally missed by IMSRA rainfall product. So this is the one example of heavy rainfall product captured by the hydro estimator over Jammu Kashmir on 2nd September 2014 to 6th September 2014 daily HE plot. If we see, these are the rainfall activity is being increasing as the day is progressing, then it start decreasing. So this has well captured this heavy rainfall event. Another example of heavy rainfall event is the over the northeastern India 21st September to 23 September 2014, and here you can see this is here it is started, then it is further increased, then it is further increased. Another example of heavy rainfall event over Gujarat and Maharashtra region observed on the 28th July to 1st August 2014, and this clearly can be seen in these 5 subsequent images. This is the recent this year example of heavy rainfall event observed in Saurashtra and Kutch region, and that is can be seen here, if we see here, this is heavy rainfall is seen here, then more heavy rainfall can be seen over this region. And I hope today also was, I have not included in that the a very heavy rainfall is taking place over the Chennai region, and that has been well captured in hydro estimator rainfall product of that. This is the heavy rainfall product seen on the 19th October 2015 HE plot through the rapid system, and this you can see, this is showing the 257.33 millimeter rainfall on that particular day over this region. So these are the sample product of all the three type of rainfall product: QP, IMSRA, and hydro estimator, generated in an image format. Another product is a snow cover. The unit is kilometer per square. Snow cover will be estimated by using the visible and shortwave infrared channel radiance from insert 3D imager. Normalized difference snow index NDSI based approach will be used to classify the image into the snow and non-snow pixel. After applying appropriate threshold value, the ratio will be estimated as NDSI visible minus SWIR upon visible plus SWIR. And product resolution is 1/1 kilometer, and product size basically it is observed over Himalayan region, and time is resolution is daily. Product accuracy greater than 90% for vegetation and cloud free pixel. This is an example of a snow cover can be seen over the Himalayan region and over Jammu or Kashmir. Another product is aerosol optical depth is there. The operational implementation of aerosol optical depth, conversion of gray count to visible radiance and brightness, temperature will carried out, cloud and sun glint elimination is elevated, and the generation of sea surface reflectance image using the darkest observation using last 20 days data set is carried out. Atmospheric correction of insert visible image for molecular scattering and gaseous absorption is carried out. Correction for surface reflectance is also carried out. After that, use a lookup table for the inversion of aerosol optical depth is used. Product resolution is 4/4 kilometer, and frequency is half hourly, daily, and monthly basis. This is the product domain: 40 degree south to 40 degree north, 30 degree east to 120 degree east is there. The values is lying between 0 to 2, and accuracy is 15 to 20% is there. This is an example of aerosol optical depth, and this, if we see this portion, this is a sun glint portion eliminated from this. This is a sun glint portion is there, white portion. Another product is a fire. This is the unit is binary. Fire product is derived by using the mid infrared channel and thermal infrared channel BT from insert imager. The fire detection algorithm employs multi-thresholding contextual techniques, which include the multi-band threshold and compare with the background kernel used. Algorithm first mask out ocean, desert, water, and cloud pixel. Initial threshold test produce the number of candidate pixel, and second test compute the mean and standard deviation of the threshold variable from the known potential fire pixel. Surrounding potential of fire pixel. After obtaining these statistics, they are used to redefine the threshold to confirm the fire by using this method. So when we carried out the validation of this product, we have a poor faith in this product. This is not coming up to the mark, so algorithm is being revised and it will be improved further shortly. This is a fire product example. As I told you, this is also showing the fire signature in the sea, and we are not very much confident over this product. Another product is a smoke product. The detail of the product is shown here. Because the time is short, we will slightly do the faster. And here I will show that this is an example of a smoke, recently, this is a current example, on 30 October, this 7 UTC and 20 UTC, there was we know there is agriculture residue burning take place over the Rajasthan, Haryana and Rajasthan. And this if we see here, this is the product is showing here, well captured is that. So smoke product is giving very good result over these areas is there. Then we also carried out the fog monitoring with the help of INSET-CD satellite. This facility was not available in the night in the earlier satellite channel images is there. For this purpose, we using 2 channel 10.5 microfarad, thermal infrared 1 and mid infrared. So I am directly showing you the detail of here. This is the if the difference between the thermal this is if the difference in temperature between the thermal infrared and mid infrared and thermal infrared is more than 2.5 degree Kelvin, then it is considered as a fog. And this can be seen. This is an example of the fog product. If you see here, this is the example of fog product. This is fog, and this is a common phenomenon in northern India of IMD. This is the fog product in daytime microphysics of images. This is the fog product seen in the shortwave infrared during daytime. This is again. So this fog advisory, basically we have advised to the forecaster by using the following result. Means as there is a nighttime fog is available from 14 UTC to 0 UTC. So we use this method. And during 12 to 14 UTC, mid infrared and sounder profile is being used. 0 to 230 UTC and sounder profile is used, and between 0 to 3 to 12 UTC visible and sur infrared as well as the sounder profile is used to detect the fog product. This is this year fog, first time fog seen in this November on the 5th November, and this you can see through rapid. We have visualized this through rapid. This is through nighttime microphysics through rapid. So we also drive the atmospheric wind vector of the this visible wind, mid infrared wind, water vapor, thermal infrared wind. 4 channel is being visible, used during daytime, mid infrared is used during the night time. Initially we carried out the tracer selection by using the 30 by 32 template window, and then we carried out the height assignment of selected tracer, and then we track the tracer in subsequent images by matching with the height, and wind is computed. Quality control is carried out by using UMAT-set criteria as employed by the UMAT-set in operational methods. So to carry out the quality control, we use last 8 images set is being used in the buffer format, and this is the sample product of the INSET-CD wind product. And this is water vapor wind, then IR wind, then the visible wind, and this then we after that we combine the IR and visible into the low level wind, and then water vapor, and then this high level wind. As such, there's 5 products are available: water vapor wind, mid thermal infrared wind, and mid low level wind, high level wind. This is another example. If you see here, this is the circulation can be seen here over this region in water vapor wind. This is another example of water vapor wind. These are the accuracy of different product, specified accuracy along with the achieved accuracy. So we are very close to the specified accuracy in an operational product. So as I told you, the INSAT 3D sounder is basically having 19 channel is there, visible channel, and 18 are infrared channel. 18 are infrared channel. SWIR, short wave infrared, is a 6 channel between 3.67 to 4.959 micrometer. Resolution is 10 by 10 kilometer. Mid infrared having 5 channel, that is between 6.38 11.33, using for humidity profile 10 by 10 kilometer. Long wave infrared 11.66 to the 14.85 10 by 10 kilometer. And we used to drive the temperature profile at the 40 levels and the humidity profile at 21 level. This is the ground cover area is there. However, we just covering this region on a hourly basis. Region A is used every hour, and every 6th hour we scan the region B. This data set is used to assimilate in the NWP model. These are the channel specification, and the purpose of different channel used for different purposes is there. It is mentioned here. Spectral response function of the different channel overlaid over SC spectrum for tropical atmosphere. So the meteorological product derived from the sounder is vertical profile of temperature, humidity, geopotential height, surface skin temperature, total ozone layer, and total precipitable water vapor, lifted index, dry microburst index, maximum vertical theta index, and wind index. And the profile is available of 3 by 3 pixel, but it is available on every pixel, provided it is a cloud free. This is an example of temperature profile in the image format of different levels. This, because this was the demand from the forecaster, that instead of the image format, we want the it should be the in profile format. Vertical profile must be there. So this facility has been introduced in the rapid system, and you can see vertical profile in these images just by clicking on any location on that through rapid. This is humidity, example of a humidity profile is there in the image format, and this is the vertical profile of humidity seen through the rapid. And shortly we are going to introduce a T5 gram utility through rapid. Means if we click at any location, T5 gram of that location will appear on the screen. And geopotential height profile is there, and these are the different product derived and the data input used for different product derived from these levels. This is the geopotential geophysical sounder parameter, product ozone, and lifted index, example of lifted index. This is layer and total precipitable water vapor. Layer is 1000 to 900 millibar, 900 to 700 millibar, 700 to 300 millibar, and then total precipitable water vapor is there. And this is dry microburst index is there. This is the formula which is used to drive that index. And this is wind index. This is maximum vertical theta differential coefficient is there. So T5 temperature profile specified accuracy was 1 to 2 Kelvin, but we are achieving 1 to 1.5 Kelvin in troposphere, and humidity profile accuracy specified was 20 to 30. We getting 10 less than 10% surface to 850 millibar, 10 to 25% 850 millibar to 200 millibar, and 15 to 20% less on a higher side. And total ozone is 5%. Validation is going on. This satellite data dissemination on a real-time basis we carried out through the dedicated website. This in this slide you can see the our website address is there, IMD www.imd.gov.in, section SatMat Dynamic Inset HTM, and these are the detail of the satellite product is there. This is the next page of that dedicated website is there, and this is the through this online animation can be seen of insect 3D. Then this is the IP address of the Rapid through which we can see analysis and visualization tool of Rapid, which already I discussed so many example. And we also archive the satellite data and images in this through online system, and this is the indexes of the archival image. We keeping last 6 month images on web server. This is, thank you.